Hey guys, welcome back. Today we're going to be talking again more about multi-step equations. This time we're going to really focus on using the distributive property. I know we did use the distributive property more so when we were clearing fractions, but we're going to not only practice that more today, but we're going to practice solving multi-step equations when there's parentheses already involved. We're not actually manipulating the equation to have those parentheses. So again, our success criteria is going to be to simplify both sides of the equation, use inverse operations to solve for an unknown, and use the distributive property, just as we discussed, as well as other simplifying methods before solving. So in this first example, it says use the distributive property to solve. So just like we practiced in the other lesson, we're going to start with the part A here. I see a distributive property on the left side, but I don't see a distributive property on the right. Looks like I can probably combine some like terms over there. So just like before, I want us to focus on simplifying each side first. So I'm just going to focus on the left side of the equation, which when we simplify, you're going to end up using one of two things. I'm going to write that as a side note here. Okay, I'm always going to ask that you simplify both sides of the equation first before you start to solve. And that's going to be to combine like terms and then secondly use the distributive property. And a lot of times when we use the distributive property, we will end up being able to combine more like terms when we get rid of the parentheses in that distributive property. Now, in this first part, we're not going to be combining like terms on the left side. It's just going to be a distributive property. But then on the right side, I do see some like terms that we're going to end up putting together. So first off, I'm going to use the property. 4 times 8 is going to be 32. And then negative c times 4 is negative 4c. Drop down my equal sign, and then on the right side, combine the like terms, 8c and negative 6c. That's going to be 2c. And now I have two sides that are simple. I cannot combine any other terms together. My other tip to you guys from the last lesson was, well, now we got to get our variables together. I see variables on both sides of the equation, a negative 4c on the left and a 2c on the right. I want to get those all to be on the same side of the equation. My tip to you was to get rid of the smaller of the two. Now, negative 4 is definitely smaller than positive 2, so I'm going to use the inverse operation. Opposite of negative 4 is going to be positive 4. So on both sides of the equation, I'm going to insert a positive 4c. Look how the left side I just scoot over. The right side, you don't really have to scoot anything over because there is space on the right. And then on the right of each of the expressions, I'm going to insert a positive 4c. That way the negative 4c and the positive 4c will cancel. You're left with 32 now on the left side. That was the whole point, to get rid of the c's on one of the sides of the equation. And now they're both on the same side. Okay, I see a 2c and a 4c. That combines together to be 6c. And then I have to drop down my positive 16. Now we have that two-step equation that we've worked with a lot in 7th grade. We want to look for any addition or subtraction first and then get rid of any multiplication or division. This positive 16 is what we want to go for. So the opposite of positive 16 is going to be negative 16. Again, the left side you got to scoot over, especially because we're going to end up subtracting. You always want to scoot it over for that subtraction process. We're going to insert a minus 16. Or a negative 16 on both sides. That's going to make the positive 16 and the negative 16 cancel. And then I'm doing 32 minus 16, that is 16. If we were to type that in a calculator. And we have 6c left over. Then I can divide by 6 on each side. And I can see if I were to reduce this fraction, I can divide both of these by 2, just to simplify this fraction, and I get 8/3. Now, don't let a fraction scare you. And you could even write this as a decimal, but if you wrote this number as a decimal, because it's a third, you would have to round it. But you could also check your solution by plugging it back into the original equation. So yeah, just with your answer, don't let a fraction make you nervous, but please keep your answer as this fraction. Don't change that into a decimal that you're going to have to round. That just means you're going to be more imprecise with your answer. So now I'm going to do this one more time in this example, use the distributive property, and this time it's got a little more going on both sides of the equation here. I see distributive properties on both sides, and I may have to combine like terms after using the distributive property. So first, let's just get rid of those sets of parentheses. First, let's focus on the left side, and then we'll focus on the right. So I'm going to distribute that -3 into the x and to the -2. -3 times positive x is -3x. And then -3 times -2 is positive 6. Don't forget to drop down that positive 7. And the equal sign. Now we can go to the right side and do the same thing, use the distributive property. 2 times x, that's 2x. 2 times 5, that's 10. And then don't forget to drop down that -12. Okay, again, I don't want to start solving until both sides are as simple as possible. Again, I'm going to have my eyes travel over to the left side. I do see like terms that I can put together, the 6 and the 7. Those both do not have x's on them. So I can combine them together, drop down my -3x. 6 plus 7 is positive 13. I'm going to do the same thing to the right side. I see I can combine together a 10 and a -12. Drop down my 2x. 10 minus 12 is -2. So now I have both the left and the right side as simple as possible. My next goal is to get the two variables on the same side. My tip to you was to make sure to grab the smaller of the two. So I'm going to make the -3x go to the other side since -3 is less than positive 2. Since it's -3x, I'm going to insert a positive 3x on both sides. Again, I have to scoot the left side over. Notice how, again, I'm just rewriting the equation with that left side scooted over, and I'm going to insert a positive 3x on both sides. That way the -3x and the positive 3x become a 0, and I'm left with 13 is equal to, combine my like terms together, 2x and 3x together, that makes 5 total x's. And don't forget to drop down that -2. And now we've got a nice little two-step equation. Get rid of any addition or subtraction first. So scoot over that 13, rewrite the right side, 5x minus 2. I want to get rid of the -2 again. Get rid of any addition or subtraction first. Opposite of -2 is positive 2. So now I have the -2 and the positive 2 canceling, and I'm left with 5x is equal to 15. Last step, divide that 5 off so that you just have a 1x left over. I want to know how many, what is the value of just one of the x's. 15 divided by 5 is 3. So that one was a nice one. It wasn't a fraction. Two different problems. Part B was a little more complex because we had two distributive properties, one on each side. We also had some like terms we had to combine together first before we could continue. Now, there are a lot of steps in that, but it all really is the same process, just over and over again with different like terms. So I've given you two different parts here in this example. I want you guys to give this a try in your first U try. Solve for E. All right, so again, we're going to practice today clearing fractions. I know you guys probably didn't have the easiest time with that on the last lesson, so we're going to practice it again on this one. You can always solve an equation with a fraction in multiple ways. One way is to begin by eliminating the fraction. The way that we did this was we noticed the least common multiple of that denominator. So if you notice in this equation, the denominator is 4. That means that we're going to want to multiply everything by that 4 because a fraction really is just a division problem. So what this is saying is 3 divided by 4. What's highlighted in blue really means 3 divided by 4. So if we multiply it by 4, if you divide something by 4 and then multiply it again by 4, you really just did inverse operations and you just get what's on the numerator. But in algebra, you can't just take this fraction and just multiply it by 4 and get rid of it. You have to multiply the entire equation by that 4 in order for it to stay balanced. So I mean the entire left side of the equation has to be multiplied by 4, as well as the entire right side has to be multiplied by 4, which is really just another distributive property. 4 times 12 is going to be 48. And then 4 times 3/4. You can type that in your calculator if you're unsure of how to, what I mean by getting the numerator left over. Just type in your calculator the 4 from the outside times 3 divided by 4. Your calculator is going to spit you back 3, which is really just the number that's on the numerator. So I get 3, don't forget about the n sitting there, that n does not disappear, 3n plus, and then the 4 also has to multiply the 5. So even though the equation looks different than the original, it really is the same proportion. Now we can solve for n. Okay, so I'm looking for addition or subtraction first. I'm going to scoot over my left side. And what is being added to n is that 20. So I'm going to do the opposite. Opposite of positive 20 is negative 20. So I'm going to put that on both sides of the equation. Positive 20 and negative 20 cancel, and I'm left with 3n is equal to 28, and then I'm going to divide by 3. So in this case, n is going to be 28/3. That would be a decimal. I could divide 27 by 3, but not 28 by 3 to get a whole number, so I'm just going to leave my answer as a fraction. Again, what I want you guys to try to practice is if the equation starts off with fractions involved, then your answer should have fractions and not decimals. If the equation starts with decimals, then it's okay to have your answer in decimals. So let's have you give this a try. Actually, this isn't your you try yet. We are going to give this a try in the second example. So that was kind of just a preview of what we were going to do. This actually looks just like a test question. So make sure you're pausing the video if you need to, if you've got any questions about what I'm about to do here. Again, I see a distributive property. So I'm going to get rid of those parentheses by multiplying that 3/5 into the two terms that are inside of the parentheses. You do not need to multiply the 3/5 times the 4. The 4 is not on the inside of the parentheses. So now I have 3/5 f plus, and I want to know what 3/5 times 10 is. 3/5 times 10, or 10 over 1. Again, we would just multiply the numerators and multiply the denominators. That's going to give me 30 over 5. And 30 divided by 5 is just 6. So that was nice. Make sure you drop down that -4. Don't let it disappear. Is equal to -7. I do see some like terms that I can combine together. Always look to combine like terms. Distributive property, and then look to see if there's any like terms you can combine together. 3/5 f, 6 minus 4 is +2, is equal to -7. Now, before I start to solve, I want to clear that fraction. You don't have to. I can actually show you two different methods of how to solve this problem. But the first method would be to clear that fraction, which is to take that denominator of 5 and multiply everything you see by that. So the entire left side, multiply that by 5, and the entire right side, multiply that by 5, which means I'm going to have to do another distributive property. And again, if you were to type in your calculator 5 times 3 divided by 5, that's the same thing as doing 5 times 3/5. The 3/5 is right there, which your calculator should spit out 3 for you, which is just the numerator of that fraction. So we have 3f plus 5 times 2 is 10, and then -7 times 5 is -35. Again, now we have f. on one side of the equation. We have no more fractions. Now I can start to solve. So I need to look for any addition or subtraction. I got that positive 10 on the left side, so I'm going to have to do the opposite. Scoot it over first. And insert a negative 10 on both sides. Positive 10 and negative 10 become a 0. That's exactly what we want, so that it's gone now. 3f is equal to negative 45. And then we're going to divide by 3. A negative divided by a positive is a negative. And 3 goes into 45, I want to say 15 times. So our answer there is f is equal to 15. Now I am going to show you an alternate way to solve this at this step right here. So let's say you decided you didn't want to clear that fraction. You have 3/5 f plus 2 is equal to negative 7. You could also start solving. Okay, so I'm going to scoot the left side over, 3/5 f plus 2. I'm going to get rid of that plus 2 by doing the opposite, so I'm going to subtract 2 from each side. Positive 2 and negative 2 end up being 0, and now I just have 3/5 f is equal to negative 9. And another method that you could use instead of doing the distributive property is multiplying by the reciprocal. Okay, if I were to take the 3/5, flip it around, and times it by 5/3, well, 5 over 5 is equal to 1 over 1, and 3 over 3 is equal to 1 over 1, which really makes this cross reduce down to just 1f. But whatever I do to one side, I have to do to the other. So if you want to do it this way, where you multiply each side by the reciprocal, once you get rid of any addition or subtraction, you can do that as well. Now I just need to do the, I'm going to make a little side note here, fractional work. I need to do negative 9, or 9 over 1 times 5/3, which again, just multiply the numerators, multiply the denominators. I'm getting negative 45 over 3, which, hey, doesn't that look just like what we had over there, which gives us negative 15. So 2 different ways of solving the same problem. You can pick your preferred method, whether you want to clear the fraction by using distributive property, using that least common multiple of the denominator, or if you just want to wait till the end. I would say the second method, the method we used over here, is more useful if you only see a fraction multiplying the variable. Any other times where you have multiple fractions throughout the equation, you'll probably want to clear that out first. So let's have you give this a try in your second U-try. Alright, so this example is pretty easy just because I think it's just like our first example, only we're dealing with decimals. And you can really just live in your calculator for this if you're unsure of how the decimals are multiplying together. So it really is just the same skill. I'm going to get rid of the parentheses by using the distributive property. So 0.2x plus, and then you could just type 0.2 times 0.7 in your calculator. See what it gives you. It should give you 0.14, and then equals 0.3x minus 0.01. Again, second goal before you start solving, get the variables on the same side. 0.2 is less than 0.3, so I'm going to move that one over to the other side. So I'm going to scoot everything over. Write everything down first, and then insert the opposite. So positive 0.2x, the opposite is going to be negative 0.2x. That's going to get these two to become a 0. And I'm left with 0.14 is equal to, I got like terms over here, 0.3x minus 0.2x. That is 0.1x. And now I have a two-step problem. I need to get rid of that 0.01, the negative 0.01. So I'm going to scoot everything over on the left again. And the opposite of negative 0.01 is going to be positive 0.01. So that's what I'm going to put on both sides of the equation. And I have left 0.1x is equal to 0.15. And then my very last step is to divide by 0.1. Okay, so if you type that in your calculator, 0.15 divided by 0.1, you should be getting 1.5 for your x. Which again, since our equation started with decimals, I like that my answer is either a whole number or a decimal. You don't have to write it as a fraction. So why don't you guys give this a try in your third U-Try? All right, so I've got one more example for you that I really want to make us be in good habits with is finding errors and being able to correct them. It says student A and B use different methods to solve the equation negative 20 equals x divided by 2 plus 7. One of the students makes a mistake. Find, describe, and correct the error. So let's take a look at student A real quick. Okay, so both of them start off by writing the original equation. Looks like in this step, the difference is they're inserting that negative 7 on both sides. Because if you notice, this piece is the same as this piece. Okay, and then the negative 20 is equal to the negative 20. So the only difference is that minus 7 on both sides, which we can do. Because really what's happening to x in the original equation is it's being divided by 2 and then 7 is being added to it. Okay, well, in order to undo that, we need to go in the opposite direction. So look for any addition or subtraction first. Notice how the first equation, x is only on the right side. There are no combining like terms or distributive properties here. So we're okay just looking for addition or subtraction to get rid of, and that's what they do in the second step. Negative 20 minus 7 is in fact negative 27. If you type that in your calculator, that's going to be correct. And then the positive 7 and the negative 7 become a 0. They're just left with x divided by 2. So far on this line, they are good. Let's see if what they do on the next line is appropriate. Looks like in order to get rid of division of 2, they multiply by 2. That's perfectly fine to do. And then they make sure to do it on the opposite side as well. And then if you were to type 2 times negative 27, you definitely get negative 54. Okay, I'm also going to check this student's work by plugging it back into the original problem. So negative 54, let's see, we've got negative 20 is equal to negative 54 divided by 2 and plus 7. Okay, so negative 20, does that equal, let's see, negative 54 divided by 2. If you type that in your calculator, you get negative 27. And then negative 27 plus 7 is actually negative 20. So that does work out. So the answer should be negative 54. Which if we look at student B right away, I can tell there's got to be an error in there because it's different than student A's answer. And student A, we checked each step and we actually checked the answer by plugging it back into the original equation. So let's take a look at each of the steps done by student B. So they decide they want to clear the fraction first. They notice, okay, we got a denominator of 2. We want to multiply everything by that 2. They take the entire right side, they multiply it by 2, and the entire left side, they multiply it by 2. Which 2 times negative 20 does in fact equal negative 40. The only problem I see here is it looks like they did this one correctly. X divided by 2 times 2 is just going to equal x, but then they did not actually times 7 by 2 because, again, I see a 7. I should actually see a 14 there. Okay, that looks like where student B went wrong. They accidentally just did not apply the distributive property correctly. So this should also be a 14. And then they start doing the subtraction of 7 on both sides, but it's not a a 7. It's supposed to be a 14, so they would actually want to subtract 14 from both sides so that this positive 14 and the negative 14 go away. And they would actually be doing negative 40 minus 14, which is not negative 47, it should be negative 54, which would jive with student A because then they both would have negative 54 as their answer. So two different routes, two different methods of doing the same thing, only student B had made an error along the way by not applying the distributive property to the second term. Okay, so we found an error in student B's work. Let's have you give this a try in your fourth U try. Read student C's work of the equation 3 minus the quantity y plus a half equals 8. I want you to read through each line and describe and correct the error in the following student's work. All right, I got one last close and check question for you. See if you truly understand what we were talking about in today's lesson. It says the equations we solve are getting more and more complex with many steps involved. As you have practiced in example 4, we need to catch our errors. What is one way you can check to see if the solution you think is the answer? To see if the solution you think is the answer, if it's correct. Okay, so what can you do to check and see if your solution is correct? All right, that covers our learning target for today to solve equations in one variable but with multiple steps. Our success criteria today, we were able to simplify both sides of an equation. We did that in all 3 examples, or actually all 4 examples, I should say. We simplified both sides. We used inverse operations to solve for the unknown, again in all 4, and we used the distributive property as well as other simplifying methods. That was more like the combination of combining like terms as well as the distributive property, okay? But we definitely focused on combining like terms as well. Okay, please go back and rewatch any sections you may not have understood, get any help, ask questions if you're confused on anything, and you may move on to your Google Form homework. Thank you. Have a great day.